How are you all? Okay, fine. Doing great, I guess. So, in this class, students, we will be learning a new topic, that is the continuation. Last week's or the last class topics, there we have completed. But this topic which we are learning in this class is the application of what we have learned in the last class. So, do you remember we have started quantum mechanics in the last class, and also there we have done Schrodinger wave equation. Hope you have learned and practiced that answer, students. Okay, so now we are going to learn how to apply or the application of Schrodinger wave equation. Okay, so put the side heading, and this class topic is Schrodinger wave equation for a particle in one-dimensional box. Mark it as an important question also, students. So what is it, ma? Schrodinger wave equation for a particle in one-dimensional box. Okay. Now, so for this, we need to consider a one-dimensional box. And also, students, see, I have drawn that figure on the board. Kindly, you also draw in your notebooks. Okay, students? So, we need to consider a one-dimensional box, and also let us assume an electron or a free electron which is restricted to move in this space. Okay? So, from the dimensions or from the borders, x is equal to 0 to x is equal to a, students. Okay. So, what is required here? We need to consider a one-dimensional box, and let us assume a free electron to move or to which is restricted inside the box, having a space or having the dimensions x is equal to 0 to x is equal to a. Okay. And also, students, let us assume the potential energy of the electron inside the box to be 0. So, write it down, V equals to 0. And also, its potential energy, it means what? The free electron's potential energy outside the box and also on the walls. Let us assume it to be infinity. So, two cases we are considering, students. One is inside the box, and the other one, second one is on the walls or outside the walls. Okay. So, inside we are assuming it to be 0. Outside and on the walls we are assuming it to be infinity. Why we are assuming like that, students? If the free electron tries to escape, okay, or if it tries to reach the walls, it cannot escape from the box. Why? Because its potential energy on the walls and outside the box, we are assuming it to be infinity. As soon as it reaches the walls, what happens? It is reflected back again into the box. Okay, students, this is the introduction. Okay, so we have taken a one-dimensional box, and we are assuming a free electron to be restricted to move in a region of space x is equal to 0 to x is equal to a. Okay, and also inside we are considering the potential energy of the free electron to be 0 for the sake of our convenience, and also outside the walls and on the walls we are assuming it to be infinity. Okay. Why? Because if the free electron tries to escape, it will be immediately reflected back into the box. Okay. So, draw the figure. Mention V is equal to 0 inside. Outside V is equal to infinity. Students, remember, on the walls and outside the box, V is equal to infinity. So, now put the side heading, case 1. So, what are the two cases, students? One, V is equal to infinity. The other one is V is equal to 0, right? So, now first case, let us consider this case when V is equal to infinity. Okay, so now way to substitute this v is equal to infinity value. For this we need to take Schrodinger wave equation for a particle along one dimension. So if you kindly turn back your pages, in the derivation we find first we have derived Schrodinger wave equation along one dimension. So here in this particular case we consider that Schrodinger wave equation along one dimension. So write down here students, Schrodinger wave equation. So kindly when I am teaching, try to follow each and every point, each and every sentence students, so that whatever is written on the board, it will be clear to you. Fine? Okay. Now, along one dimension is, below write down, d square psi by dx square plus 8 pi square m by h square into e minus v into psi is equal to 0. Once again for you, d square psi by dx square plus 8 pi square m by h square into e minus v into psi is equal to 0. So here we have taken v is equal to infinity. Kindly substitute this value in the place of v. So next step, d square psi by dx square plus 8 pi square m by h square into e minus infinity into psi is equal to 0. Okay. Now here next step, d square psi by dx square plus 8 pi square m by h square into minus infinity. So e can be neglected when compared to infinity into psi is equal to 0. So next step, students, d square psi by dx square minus infinity into psi is equal to 0. 8 pi square m by h square into infinity is equal to infinity, and hence d square psi by dx square minus infinity into psi is equal to 0. Okay students? Right. Now if this minus infinity into psi, if we bring it to right side, it becomes plus infinity into psi. Okay. So write down the next step, d square psi by dx square is equal to infinity into psi. Okay. So from this expression students, look here, from this expression, psi is equal to d square psi by dx square into infinity. Okay. What is that students? Psi is from this expression psi is equal to d square psi by dx square into infinity. Okay. So in the denominator there is infinity. So anything by infinity value will be 0, and hence finally we are getting psi value as 0 when v value is infinity. So this is about case 1 students, when v is considered to be infinity. Okay. So you remember this one. V value is, when v value is infinity, psi value is 0. Where we have considered v value to be infinity students? Outside the box and also on the walls of the one-dimensional box. Okay. So remember this one. When v value is infinity, psi value is 0. Okay. Next, what is case 2? When v value is 0. Okay, write down case 2, when v value is equal to 0. So again take students Schrodinger wave equation for a particle along one dimension. So d square psi by dx square plus 8 pi square m by h square into e minus v into psi is equal to 0. So the same equation which we have taken in case 1 students. Okay. So we did not change it. The same expression we have taken. Now substitute the value of v as 0 in the place of v. So what do we get students? Next step, write down d square psi by dx square plus 8 pi square m by h square into e minus 0 into psi is equal to 0. Okay, in the place of v, write down 0. So, d square psi by dx square plus 8 pi square m by h square into e minus 0 into psi is equal to 0. So, e minus 0 what students? E. Okay. So, next step. D square psi by dx square plus 8 pi square m by h square into e into psi is equal to 0. Okay. So, this is the step after this step students. So, what to do after this step? I will tell you. So, now students write down. Let us consider 8 pi square m e by h square as k square. Okay students. So, we will consider this value to be k square. So, after considering 8 pi square m by h square into e as k square, what happens to that equation? So, write down d square psi by dx square plus k square psi. Okay. Now, this whole portion is now k square. K square into psi is equal to 0. Written? Okay. Now, students, this is a differential equation and the solution of this equation is psi is equal to a sin kx plus b cos kx. So, we need not derive the solution of this equation. So, directly we will take the solution. Okay, we will not derive but we will directly take the solution. Okay, you can write here. The solution of this differential equation is psi is equal to a sin kx plus b cos kx, where capital A and B are constants. Okay students, understood not till here? So what did we do here? This whole portion we considered it as k square and the solution of this equation is psi is equal to a sin kx plus b cos kx. Okay. So we have restricted the free electron to move in a region of space x is equal to 0 to x is equal to a. Okay. So we will take those two conditions, x is equal to 0 and x is equal to a. So first write down below this, taking x is equal to 0. Let us see how this equation changes when x is equal to 0 and when x is equal to a. Okay. So write down, taking x is equal to 0 students, psi is equal to a sin k into 0. X we have taken 0 la. Okay, psi is equal to a sin k into 0 plus b cos k into 0. Okay, below write down. Psi is equal to 0 when x is equal to 0. Why? Because in the beginning, what did we learn students? Inside the box, v is 0. Outside and on the walls, v is considered to be infinity. So here what we are mentioning, psi value is 0 when x is equal to 0. X is 0 means on the walls v is equal to infinity. Case 1 we proved that when v is infinity, psi value is 0. Do you remember that? Yes. So psi is equal to 0 when x is equal to 0. So for your information you write down in the brackets, because where x is equal to 0, v is equal to infinity, and when v is equal to infinity, psi value is 0. Once again students, the solution of this equation is psi is equal to a sin kx plus b cos kx. Taking x value as 0, psi is equal to a sin k into 0 plus b cos k into 0. Okay. Now, immediately after this, we need to mention when x is equal to 0, psi value is 0. Why? Because when x is 0, v is infinity. When v is infinity, psi is proved to be 0. Okay. So, therefore, now this expression, this equation, psi is 0. Okay. A sin k into 0 value is 0. Why? Because sin 0 value is 0 plus cos 0 value is 1. Hence B into 1, B. Therefore, B value is equal to 0. Okay. Now, so this portion is now 0. Okay, students. Next, taking x is equal to A. Taking x is equal to A. Substitute x value A. So, what is remaining here? Psi is equal to A sin, A sin kx. So, psi is equal to, 1 second students, psi is equal to A sin kx. So, it is equal to A sin ka. Okay. So, write down that one line students. So, taking x is equal to A, psi value is equal to A sin kx. Okay. This equation I have taken. So, now this portion is 0. Okay. Leave it. So, psi value is equal to A sin kx is equal to A sin k into A. Why? Because we have taken x value as A. Okay. Again, sin is equal to 0 when x is equal to A. The same reason what we have learned here. X is equal to A means it is also on the walls where V is considered to be infinity. Okay, students. So, substitute these values now. So, psi value 0, psi is equal to 0 is equal to A sin k. Fine? Understood this time? Psi is equal to A sin kx, psi is equal to A sin ka. So, psi value is 0 when x is equal to A. The same reason. Therefore, 0 is equal to A sin ka. Okay. Now, sin ka is equal to, bring it to left side. Sin ka is equal to 0 by A. So, which is with the sin ka will go to the denominator. Okay. So, therefore, sin ka value will be equal to 0. 0 by anything is 0. Hence, sin ka will be equal to 0. So, students, sin ka value is equal to 0. Now, that 0 we can take as sin n pi. What is the sin n pi, students? So, the value of n pi radians is 0 according to mathematics. Okay. So, we are not taking here 0. If we take here 0, we cannot proceed forward. And hence that in the place of 0, we are taking sin n pi. Okay. Because the value of sin n pi is 0. Instead of writing 0, we are writing sin n pi. Okay. So, sin ka is equal to sin n pi. So, ka value will be equal to n pi. K is equal to n pi by A. Simple division, right? So, k is equal to n pi, students. K is equal to n pi by A. Squaring on both sides, what do we get? K square is equal to n square pi square by A square. Next, but this k square value, okay, just turn back your page and say, what is the value of k square? Which portion we considered it to be? K square, 8 pi square me by h square. Okay. So, k square value is n square pi square by a square. But k square is nothing but 8 pi square me by h square. So, we will equate these two. 8 pi square me by h square is equal to n square pi square by a square. Okay, students. So, now what you do? Cancel pi square, cancel it. So, what remains? 8me by h square is equal to n square by a square. Okay, students. Understood now? So, from here, what did we do? Pi square, cancel. So, what's remaining? 8me by h square is equal to n square by a square. So, finally, last step, students. Capital E from this expression, capital E is equal to, what will you write? Can you write on your own without seeing on from the board? E will be equal to n square h cross multiplication. N square h square divided by 8 me square. So, energy of the free electron can be calculated using Schrodinger wave equation, which is moving in a one-dimensional box where inside its potential energy is considered to be 0 and outside and on the walls its potential energy is considered to be infinity, students. So taking these two cases into consideration, we could calculate or we could derive the formula for the energy of a free electron as n square h square by 8 ma square. So draw a line till here. This is your answer for Schrodinger wave equation for a particle in one-dimensional box. So students, this is all for this class. So this is an essay question, students, and also a very important question from quantum mechanics. Okay, so I will continue in the next class with the new topic, students. So take care, have a nice day, and bye bye.